Hi, my name is Richard Yen. Welcome to Scaling the Wall of Text, Best Practices for Logging in PostgreSQL. This talk is for people who are new to Postgres, but also for those who want to improve their experience administering Postgres databases. Okay, so just a little bit about myself. I am a software developer and previously a support engineer for EnterpriseDB. I've been working there since 2015, and currently I work with Postgres to build Golang and Python apps. I was also previously a pro web developer and eventually became a Postgres DBA. I've been working with Postgres since 2002, and it is my favorite database, and I really feel privileged to be able to share some of my experiences with you. So you might be wondering why we're doing a logging talk. It seems like logging is just something that just happens, but in Postgres, there are some things that need to be configured. Now, logging is important and often overlooked. Most people are interested in security, or maybe they're interested in performance. But the reality of working with databases is that bad stuff does happen. So in my experiences as a developer and also as a DBA and more recently as a support engineer, I've come across many customers and people who have experienced problems with their database, and because they need to investigate what's going on, they actually end up spending a lot of time. So when bad stuff happens, like a database crashes or the data gets corrupt, there is an investigation that needs to happen, and we have to answer certain questions like who caused it, or what happened, when did it happen, why did it happen, how did it happen, all these kind of things that you want to figure out so that you can prevent it from happening again. And this process, it could take hours, it could even take days, and that amount of time is cost to the company or the organization, which is why we have to configure logging well. And when we are able to configure logging well, we can recover and move on quickly. As the saying goes, an ounce of prevention is worth more than a pound of cure. So spending a few minutes or hours configuring your logging well will save you a ton of hours later on to investigate into a root cause. Now, working as a support engineer, I've come across many different situations with customers, things like database crashing, replication being broken, inability to install some extension, or having problems with an upgrade. And all of these things we were able to resolve when the logging was configured well. Not only that, just as a person of curiosity, or a person who's responsible for database, logging can tell you a lot of things. It can tell you, things like how long the query takes. Maybe if you have a history of logs, you can actually kind of see how query time has changed over the past few months or over the past few years. It can tell you things like maintenance activities, like out of vacuum, performance bottlenecks, like lock contention, or maybe missing queries and stuff, missing indexes and stuff like that. So the log can tell you a lot of things that are useful, and if you have them available, it could actually be a very valuable thing for not only you, but also for your organization. So let's dive in. Let's talk about what Postgres has to offer. So the Postgres logging parameters, if you look in the postgresql.conf file, you'll see that it's divided into three sections. First, it talks about where to log, and then then you can configure things about when to log, and then finally you can configure things about what to log. So I'm going to go through each of these step by step. Where to log. So this is a brief summary of parameters that are related to where to log things. So, for example, like log destination, you want to send things to a std out, like a log file on your server, or you want to integrate it into things like syslog or some other event logger. The logging collector is actually something that you can turn on and off, and that is sometimes useful in case it's just too many things are getting generated at once and you're trying to do an investigation and new information is coming in and preventing you from reading things well. So you can turn that off temporarily, you turn it back on without having to restart the database. Log directory and file name, these things are basically what you would expect. Now, the thing about log directory is that it logs things into Postgres, the same directory as postgresql.conf and pgxlog by default. So it's that pgdata directory. I've seen many people use a separate partition for the log directory. And this is a good idea because some of that I/O that's used to write to the log, you don't want that to be interfering with the I/O that's being used for retrieving data from the database. So a custom partition is a good idea. By default, the log file name is just postgresql-year, month, day, hour, minute, second .log. For some people, that might be a little too granular, so they just do year, month, day. Some people may need to prefix it with something else besides PostgreSQL. Maybe they want to have a log name include their application or their product name, depending on what their needs are. So you can configure that as well. Log file mode is basically like the chmod. It allows you to change who gets to access the log and who gets to write to it, things like that. The last three are related to rotation. So for some, having too many log files around might be a bit excessive. So they will rotate once a day or rotate, maybe they don't want the files to get too big, so they rotate at a certain size. And depending on those, the rotation, once the rotation happens, the new location may be the same file name as something that already exists. And depending on your needs, you can tell it to truncate that file. So like, let's say today's Thursday, and I set my log file as postgresql-thu.log. If I rotate and it's Thursday again, do I want to truncate that or do I want to append to it? That log truncate on rotation is the parameter that allows you to control that. Okay, so that is where to log. The what to log, I'm going to go into that now. Things like log min messages and log min error statement, it allows you to have some control about when the message gets logged into the file. Log min messages will print a message saying like index was created or this person logged in. So these kind of messages get printed. Log min error statement, this is the level at which not only is that message written, but also the statement that caused that message to be written. So like, for example, like if you have a syntax error, instead of just saying, a syntax error, it would say syntax error and then the query that caused the syntax error. So that way you can actually figure out what caused that syntax error. Okay. Log min duration statement is a parameter that allows you to filter out the slow queries. So anything that takes more than this minimum time, so like let's say 1 second, any query that took more than 1 second will get logged as the statement itself will get logged. The last three that I have to share here are involve sampling. So these are kind of newer. They were introduced in versions 12 and 13, and this is for commonly logged queries. So like, let's say you're logging everything. Now, if you're logging everything, it could be very noisy, and especially for the very commonly run queries like select everything from users list or something like that. These three parameters allow you to say, hey, I'm only gonna sample stuff that's maybe like 50% of those times, right? The sampling rate, I'm going to sample only a certain percentage of of those queries. So that way you don't actually create too much noise in the log. Okay. Finally, the when to log section. So I'm going to give you I'm going to give you some examples of the when to logs. So if you can see these two log message samples, it says a time and then a particular number, and then it also says this fatal roles some users do not exist. The next one says warning, right? So this word fatal and this word warning, this is the logging level, and the logging level are the things that we set for log min messages and log min error statement. So like I mentioned earlier, log min messages will print out the message, there is no transaction in progress, or role some user that does not exist. And the log min error statement will also provide any query that was issued to print those two messages. Now, the other values that you can use are debug, info, notice, warning, error, log, fail, and panic. Now, that's a lot of different options. And how do we choose? So the debug level, so you can see debug 1, debug 2, those levels are primarily for PostgreSQL developers. We're trying to figure out what a variable's value is, or where a bug might be. So for most users, we don't need to use debug. Info is something that is implicitly requested by the user. So let's say I say vacuum verbose. Now, because I said verbose, it's going to vacuum and print other stuff in addition to the vacuum. Now, that stuff is going to be written to the log as info messages because I requested a verbose vacuum. So it'll provide that information for me. Now, notice level is Postgres trying to provide proactively some information that might be useful to the user. So let's say I created a primary key. So if I create a primary key, it's a constraint. So when I say I want to create a primary key, Postgres says, "Oh, I have created this constraint for you." But because I wanted the notice level, it'll also print saying, "Oh, by the way, I created an index because in order to have a primary key, we need to have an index. So I created an index for you." So that notice, it provides that extra bit of information for something that I wanted to do. Okay. Warnings are things that are potentially dangerous, but not at a database level. Like, for example, if I actually have a commit statement, but I didn't begin a transaction. So let's say I updated some tables and then I hit commit. Because I didn't begin the transaction, Postgres will say, warning, no transaction is progress. So just as you see on the screen. So that could actually be a signal to me as a developer, hey, I need to begin a transaction somewhere in my Python code or my Java code or whatnot. Because if I inadvertently do something like I update all the tables, all the rows of a table, then I might introduce some data corruption by inadvertently updating more than I should. So that warning tells me, the developer, hey, go look somewhere for something that if you don't fix and something bad happens later, it might cause widespread chaos. The error level is any kind of command that any kind of situation where the command had to abort. So like, for example, like a syntax error. Because I can't finish a query with a syntax error, it prints out an error message to the log. The fatal and panic are similar. Fatal is any kind of situation which caused the current session to abort. So like, let's say I try to log in with some user. The some user doesn't exist, so therefore the session has to end. So that's why it gets logged as fatal. And panic is the one that causes the entire database to crash. So let's say something is missing or some kind of segmentation fault happens. then a panic will be printed to the log. The one I haven't mentioned is the log level. So the log level is any kind of information that is interesting to the administrator. So for example, like let's say I had a checkpoint. The checkpoint, when that happens, a log level message will be put into the log. So that way, later on, if I want to find out when the last checkpoint happened, I'll see, oh, this is when the last consistent state is available. Okay, so that's when to log. So by setting the logmin messages and logmin error statement, you get to these particular levels, you get the behavior that you want. Okay. Now, finally, the what to log section. The what to log section is things like log duration and log statement. Now, we don't want to be confused with log min duration statement for these two, which I'll explain to you very shortly. And then the last two, log replication commands, yes or no. And then finally, what I think is the most important parameter, which I'll talk about in a few seconds, is log line prefix. Okay, so just a quick bit of clarification of log min duration statement versus log statement and log duration. Like I mentioned earlier, log min duration statement logs the statement and duration, but it does that after the query has finished. So like let's say this query took 1 second. Now it's only going to know that it took 1 second. Then it can actually print this, right? So it has to wait till it finishes to be able to write, hey, this query took this many seconds. And because it happens at the end, it doesn't, I think Postgres community has decided that it's not really that relevant to log the parameters. So it just says, hey, this query took this long. So if you have any placeholders in there, they won't get logged. Now, on the other hand, log statement will log the statement before the query is executed. And then in addition to logging that statement, it will log all the parameters that you passed in to that query. Now, the thing is, because you don't know when, how long it took to run the statement, because you're printing it before it ran, we can't filter. So we can't only filter the ones that are slow. However, the nice thing about this parameter is that when it's turned on, because it's logging everything before the query is executed, you'll be able to track, let's say the query causes the database to crash, or the query causes a fatal error. Then you can actually go back and say, oh, this is the last query that happened before the crash or before this person was kicked out. So that's actually very useful. So it is a give and take. It's nice to be able to log both of these, to use both of these parameters, but knowing that log statement logs everything because it can't filter, you may or may not want to have that on all the time. Having said that, log statement does allow you to filter on all statements, including reads and writes, but you can also set it to only log write statements, anything that modifies the database. And then you can tell it to only log DDL changes to your tables and your indexes and stuff like that. Okay. I mentioned earlier what I think is the most important parameter, which is log line prefix. And this is the value that I think everyone should use. Basically, it is a timestamp, a process ID, line number in the session, transaction ID, username, database name, application name, and client host address or host name. There are other values that you can use as part of this log line prefix. So every line in the log will be prefixed with whatever you set it to be. And this is a list of what available wildcards there are. I know it's a bit small to see on the screen, but this is something that's completely screenshotted off the documentation. So please take a look at the documentation if you want some more information about how to use logline prefix. Now, the nice thing about providing more information to logline prefix is that it provides more clarity to anyone who's reading the log. so you can get more information about who did what happened, when did it happen, where did it come from. It also gives you control over filtering and sorting, grouping different lines together, because like let's say you have several users using a database at once. Somebody might log in, and then a lot of other activity might happen by someone else. And then finally, that first person issues a query maybe like a minute or two later. To be able to use logline prefix with Unix tools like sed and awk or grep, it will allow you to be able to sort that all out and say, hey, this user did this stuff in this session, and this other user did this stuff in this other session. So it does give you that kind of flexibility. The reason why I want to make a big point about this is because the default value for logline prefix is just two wildcards. It's just basically a timestamp and a backend PID. And before Postgres 10, which is already obsolete, it's actually blank. So it's really up to the users and administrators to be able to set this properly, so that you actually have ability to do good research on a log later on. In my experience as a Postgres support engineer, I actually compiled a list of different postgresql.conf files that our customers were using, and I discovered that only 40% of the users, 40% of the users are keeping the default. So 60% users change it, but 60% is actually not everybody. So some people out there might not be aware of the importance of logline prefix. So don't neglect this parameter. Now, just to give you an example of some of the things that I mentioned earlier about logline prefix, here's an example of somebody dropping a table. Now, the default only shows the timestamp and the PID, right? And it doesn't show you who. So it could be a bit tricky to figure out who dropped this table. However, if you actually have the logline prefix, like I had mentioned earlier, you'll see the timestamp, PID. This is the second entry of this person in the session. The first entry would be connection received. So second entry, this person was authorized to use the database. Third entry, this person actually dropped the table. Right? Transaction ID, it shows you that it wasn't done within a transaction. It was just issued straight into PSQL or by some application. Username, database, and then the client IP address. So where this query came from. So as you do research onto who dropped this database, you can actually pinpoint it down to the server or this laptop or whatnot. So again, logline prefix is very, very useful and important. Okay, so I've talked about the different parts of the postgresql.conf, what the logging parameters are, which ones to focus on. In the remaining time that I have, I want to just share with you some tips on what to look for. And I know I don't have a lot of time, but I'll try to quickly go through them. So first, try to look for spikes in different logging levels. Warning, fatal, and error are the ones that you want to kind of pay attention to. If you use something like Splunk or some other log aggregator, try to filter on these keywords. So that way, if you ever see a spike on them, like maybe right around the time of release of an app, you'll discover, oh, hey, actually, I got a spike on errors. And then when you actually look into it, oh, maybe this person had a typo with their table name or had a syntax error in their query. So that logging level is actually logging based on the level, the keywords are actually very helpful. Pay attention to hints. So if you look for the word hint in a log, it actually might give you some ideas into what some performance issues are being encountered by the database. And then, again, like I mentioned earlier, be sure to use Unix tools like grep and sed to be able to figure out different patterns, group the entries together, so that way you can see what different users are doing, and that'll definitely speed up your investigation after an incident. Pay attention to application bugs. Like I mentioned earlier, like with login levels, if you have application bugs, you'll probably see a lot more of that keyword error. Okay. If you ever see anything about replication, be sure to check your replication slots. Be sure to check your wall keep segments parameter to make sure that these are set properly. And then look for keywords like dead but not yet removable when you're working with auto vacuum. So if you see this might indicate that there might be some kind of idle transaction somewhere or some really, really long running query that's preventing auto vacuum from working properly and completing its job. Look for temp files. When you see temp files being created, that probably indicates that work mem is too low, and you might need to increase your work mem so that your sorts may be done faster and all within memory. And then finally, look for things like locks and deadlocks, and cross-reference them with PG site activity to see maybe some kind of queries are holding locks too long. Maybe you're forgetting to roll back or commit a transaction. Okay. So in summary, be sure to set your logline prefix. That's the most important variable. And then log as much as you can. You can use a separate partition if you have to. And then be sure to look for spikes, look for keywords, and see if they correlate with any kind of change within your application stack. And pay attention to patterns. And then there's some additional tools out there that I didn't get to talk about. Things like PG Badger and AutoExplain. These are actually very helpful, especially AutoExplain. It gives you some window into nested queries. So if you ever have sub-selects or queries that are run within a function, AutoExplain will actually give you some additional information to be able to do some investigation into any kind of performance issues. Okay, so with that, that's the end of my talk. I'm really thankful. Thank you for joining. Glad you were able to come listen. I really hope that it was useful to you, and looking forward to, I hope that you guys, you can also find other presentations at Posette very useful. Have a good time.